So here, the scientists that are working here, and we said we have very large R&D, but they're not all doing the same thing. You have scientists that only work on skin biology, you have scientists that only work on ingredients technology, you have scientists that work on biotechnology and applications for delivering ingredients. And it's here that this takes place. How many of you have heard something say it works to block the receptor that causes fill in the blank? Or it helps to awaken the youthful gene. And what does that mean? And it's a lot to take in, but I'm going to show it to you in a very simple visual way, exactly how that testing is done. And it is done on cells and on genes. So in the case of skin, the scientists would take a skin cell, because that's what we're working with, and they would say, what are the things that we want to do? So there are genes that do good things, like collagen synthesis, like hydration, like naturally occurring antioxidants in our bodies, superoxide dismutase. And then there are bad things. There are enzymes that destroy collagen, and they're very, very damaging. So they're saying, they posit that this ingredient that they're very hopeful, and they've been studying, and their colleagues have said, we think this is great, go to the next scientist. And what they do is they take something called a gene chip. So in your program, you're going to see it's called a gene chip assay, which for a scientist means a test, basically. And it literally is a chip, like a microchip, or a SIM card that goes into your phone. And it's about that size. It's actually about this size. They can be bigger or smaller. And in the case of skin scientists, they're only looking at genes. A neurologist would be looking at nerve cells. Here they would say, okay, I'm going to look at the gene that causes collagen synthesis, antioxidants to be generated, hydration, whatever it is that they're looking at. And they literally put it on something that looks like this with little wells. And now they're going to introduce the ingredient that they're exploring to see, does it have the response? But they have to be able to see it. And how do they see it? They actually tag each of the cells with a color. And so once it's introduced, it literally will, in the case of a gene, it will either upregulate, which basically means turn on, or downregulate. So in the case of good genes, you want to turn them on. In the case of bad genes, you want them to simmer down. Don't go so crazy there. And it can happen regardless of your age. So superoxide dismutase is actually a marker that scientists look at to tell the age of skin. So you could be 25 and have very low levels of SOD, and they would say, that's skin that's aging more quickly, or a body that's aging more quickly. So here the scientists have tagged it, and they tag it with a color. Then they're going to test the ingredient, and then they're going to wait, and they're going to look. And they're going to say, did it light up, or did it not light up? These scientists have tagged the positive genes with the colors red and orange and pink. So Camilla has tagged her ingredient, she's introduced the ingredient she's testing, and this is what the gene looks like. What does it tell her? Is that something that Camilla would then share with her colleagues and say, this is an ingredient that I think you really have to look at? We want to put it into a formula?
Yes.
Yes. Natalie tested another ingredient on the same cells, and this was her result. Would it be something that she would want to move forward with?
No.
No, because they're literally not seeing it. So in the case of Camilla, she's saying it's done something extraordinary, and she's going to give it to her colleagues who work in biotechnology and how to deliver these ingredients in the final formulation. There are many different delivery systems. Liposome is one that people are often familiar with. In this case, our scientists have worked with actually our own plants again. The green tea leaf, a full intact leaf is taken, it's submerged in an enzyme, just like papain dissolves dead skin. And what you expect to get is something like a leaf you see in the fall, like a skeleton. But actually what the leaf looks like when the scientists look at it is like a black fishnet stocking, or a natural fishnet stocking, or a green fishnet stocking. But this is what it looks like. And for every single hole in the fishnet, it's a cell, a living cell. And they will go through and make sure that they only have the intact cells. That's basically the cell now, it's just the cell wall. And it actually mimics the exact same structure of our skin cells. They infuse it with the active ingredients, and they put it into the products. In this case, future response. And it's that vehicle that lends the time release benefit that you'll hear about when you're speaking about future response. It's a 24-hour time release, so those ingredients are delivered to the cells at a rate that they can absorb it for optimum benefit. So now when you look at future response, are you going to see just a cream? Or are you going to see Fishnet stockings filled with active ingredients. Exactly. So it makes it targeted time release. So let's come with me here, and we're going to finish by just bringing it all together in a really simple, elegant video. And then Mel is going to take it back with you.
I'm letting everybody go first.